These are the notes for 5.4. It is so similar to 5.3. You can probably get by with watching just this first video, but I am going to post, there are 4 examples in section 5.4, and I will do all of them, but I think you could probably get away with just watching the first one, and mainly watching this one because it has the identities that you're going to need to use. So right here, we have our sign of sum or difference identities. And again, I'm not going to tell you how they got them, but let me tell you something you can do to recognize and remember. Sign sum identity. Sign, if you think sign starts with an S, has the same sign here as it does here. Unlike cosine, which is switched, or converse, which is another way of saying switched, but sign has the same sign. So if it's a difference, it's a difference. And the other thing that that is different about the sign identity is you will notice it is sine cosine, cosine sine. So sine A, cosine B, cosine A, sine B. So that's the way you can remember. And then there's the tangent sum or difference identities, a little bit more complex, but you'll notice that the top shares the same sign and the bottom has the opposite sign. Top shares the same sign, bottom has the opposite sign. So those are things that you can do to try to remember. Again, because of the way this is all turning out, you will be able to look up your trig, or you'll have your trig identities. I'll probably even just give you a page that has them all listed on there, but it does make it a little easier if you can just kind of recall them quickly. So let's do example 1. We're going to find the exact expression. So sine of 75. So remember, anytime they say exact, they mean not using the calculator, but instead I need something that's got like square root 3 or square root 2 or whatever, something from the unit circle. So again, like we talked about the other day, I don't know anything. My unit circle, I know 30, I know 45, I know 60, I know 90, but I don't know 75. But 30 and 45 added together is 75. So I could write this as sine 35 degrees plus 45 degrees. Really? 30 degrees. I don't know why I put 35. Sine of 30 plus 45 would give me sine 75. And if I use my identity, that's going to be sine, we'll call this A and this B, sine 30 cosine 45 plus cosine 30 sine 45. And then I just have to replace those with the numerical values. So on a 30-degree angle, sine is, remember, sine is your y value. So sine is 1/2. Cosine is square root 2 over 2. Plus cosine is square root 3 over 2. And sine is square root 2 over 2. And when I simplify that, I get square root 2 over 4 plus square root 6 over 4, which becomes square root 2 plus square root 6 over 4. All right, so same thing. This time we're going to do tangent, and our tangent problem happens to also be in radians. That's okay. Remember, just like we talked about the other day, it works the same for radians as it does for degrees. So let's see, I need tangent of 7 pi over 12. So let's see, I know pi over 6, pi over 4, and pi over 3. Which if I write all of those with a 12 on bottom, and I know we did this the other day, but just as a reminder, that would make this 2 pi over 12. This one would be 3 pi over 12. And this one would be 4 pi over 12. Which means I can use these last two with the sum identity. So I'm going to do this identity. And let's see, that'll be tangent of pi over 4 plus pi over 3. And that's going to be tangent pi over 4 plus tangent pi over 3 for 1 minus tangent pi over 4 tangent pi over 3. So now we just have to go in and plug in the numerical values. So let me change colors. Let's see. I'm actually probably going to have to erase some to get room here. But let's see if I can go. All right, so tangent of pi over 4 is, oh, tangent of pi over 4 is 1. Oh, I don't know why I wrote tangent. So this is 1. Tangent of pi over 3 is square root 3. And then that was, so I got 1 minus 1 times square root 3, which gives me 1 over square root 3. I'm sorry, 1 plus square root 3 over 1 minus square root 3. Now, technically, we can't leave it like this because it needs to be rationalized. So before I rationalize, let me erase some of this so I can use this area. Okay, so now reminder on how you're going to rationalize something that is a binomial on bottom. In order to rationalize this binomial, we're going to multiply it by its conjugate. So I'm going to rewrite it over here so you can see it better. I have 1 plus the square root of 3 over 1 minus the square root of 3. To rationalize, we're going to multiply by the conjugate of the denominator. The conjugate is same two terms with the opposite sign in the middle. So same two terms with the opposite sign in the middle. If I multiply the bottom by the conjugate, I have to multiply the top by the conjugate. I'm just going to, you'd have to FOIL out the top, but I'm just going to rewrite it as 1 plus square root 3 over 1 plus times 1 plus square root of 3. And on bottom, because they're conjugates, you would just multiply first and last. So it would be 1 times 1 is 1, square root 3 times square root 3 is 3, and it'd be minus 3. So the whole thing ends up being, I don't know why it's doing that. The whole thing ends up being, so now I'm going to FOIL. So I end up getting 1 plus 2 square root 3 plus 3 over negative 2. And I can add my 1 and my 3 together. And that gives me 4 plus 2 square root 3 over negative 2. And these outside pieces will all be divisible by 2. So I can divide them by 2. And I end up with 2 plus square root 3 over 1 negative. So I don't have to write this part. So, and then probably what I would do is change this to negative and change these both to negative. So it'd be negative 2 minus the square root of 3. All right, so that is all for that one. And that one was a little bit more complicated than the ones we did previously, only because we had to rationalize that denominator. But other than that, the whole plugging in and actually using the identities part's not that bad. All right, so I'm going to erase some of this stuff, and then we're going to do C. Obviously, C is using the sum difference identity. So, yikes. Get this stuff out of the way real quick. Okay. All right, so if I look at it, it's the sum difference identity, because remember, they have the same sign as what they started with. So if I look at this the way it's written, I don't know what sine of 40 is, and I don't know what cosine of 160 is. But if I were to rewrite this as sine of 40 minus 160, then that gives me sine of negative 120. And so then I just have to think, do I know what the sine of negative 120 is on the unit circle? So this would be negative 90 plus an additional 30 degrees from there. And do I know what that is? So that would make this my reference angle 60. So whatever my ordered pair is at 60, that's going to be my, those are going to be my values. I just have to remember that in quadrant 3, all students take. The only thing that's positive is tangent, so my answer is going to be negative. And at 60 degrees, sine is square root 3 over 2. So that's it. So that is all for this one.